age idea is mainly an assumption. And notice the title of this. A single late Wisconsin Laurentide glaciation Edmonton area in southwest Alberta. There used to be 3 or 4 there, they claimed. And now there's only one, and it's at the very end of their time scale in what's called the Late Wisconsin. There was none before in their time scale. There's only one. In most areas on land, there's evidence only for one. It's only in a few special areas, mainly at the boundary. And they can be explained by an ice sheet that surges, backs up, retreats, surges again, things of this nature. You can explain some of these exotic things of different till sheets with sand in between it by one ice sheet that moves, that is dynamic. Will there be a future ice age? If anyone saw that movie The Day After Tomorrow and thought seriously of it, you're probably really sweating it, aren't you? In fact, the New York Times said, the next ice age is due soon. If the past is any indication, the Earth is at the end of another such warm period poised to descend into a new ice age. Well, why would he say that? Well, because we are still in the glacial-interglacial cycle, they believe. Interglacials only last 10,000 years, and it's been 10,000 years since the last one. So guess what? We're due any time now. And some people think global warming will trigger it. That's the idea of the Day After Tomorrow movie. Global warming will trigger the next ice age. That's quite a stretch meteorologically. But you can relax. There never will be another ice age. Since the flood caused the ice age, and the rainbows have promised that there'll never be another flood, there'll never be another ice age. So you can just relax and not worry about it. You're not going to have another ice age. Some important features of the model. Now, the reason I'm pointing these out is because I've noticed over the years some confusion on some of the details of this model. This model has cooler summers because of the volcanic ash, but it has warmer winters. Why does it have warmer winters? Because of the warm water is going to, and the latent heat is going to steer that spread over the northern hemisphere, and it's going to subdue a lot of the winters. Not going to be so cold. Also, the ice sheet develops more or less in place. It doesn't have to develop in northern Canada and move at a glacial pace down into south of the Great Lakes. It develops more or less in place. In other words, you have an instant winter, and it just it just piles up in the northern United States. So the ice sheet develops generally in place. It doesn't have to move down from northern Canada. Also, I don't see any reason why the ice age wouldn't develop immediately, because you have every ingredient there: the warm water, thick volcanic ash, and aerosols in the atmosphere to cool the land. I don't see any reason to delay it. Now, some people want to delay it because they want a lot of geological activity going on after the flood called post-flood catastrophism, which I have a hard time seeing the evidence for. And so they say the ice age has to delay 200 years. Well, if that's the case, the ocean would cool off so much that you might not even have one on that idea. But everything's ready right there after the flood. And the land can cool off in a matter of a day after the flood. Just look at it nighttime. There's some places in Montana they cool off 60 degrees every day in September on a clear, calm night. 60-degree diurnal change. That's how fast the land can cool. Very fast. So it's not going to take long for the ice sheet to occur. And some of the reasons why the winters would be warmer, a guy did an experiment where he kept his model everything the same, but he took off the ice cap over the Arctic Ocean, just the ice cap, and he kept the temperature of the water at the freezing point of seawater, which is about 29 degrees Fahrenheit. Because of the salt, it's lower than 32. And these are the temperatures warmed over the winter this much. These are in centigrade. Right at the North Pole, it warmed 40 degrees centigrade or 70 degrees Fahrenheit in winter. Look at that, 20 degrees centigrade or about 38 degrees Fahrenheit right in northern Siberia there. Tremendous warming, just getting rid of the sea ice. In fact, I think this is a major reason why the lowlands of Siberia and Alaska were not glaciated, because of the warmth of the not having any sea ice in the warm water, the warm onshore flow. So because of this, no sea ice, that'd be a factor in causing warmer winters during this. So you have cooler summers, warmer winters. You wouldn't have much of a seasonal change. So we're going to have a little intermission, and I just want to say a few things that when I'm out speaking, I sometimes speak for Answers in Genesis, but when I'm not, I try to promote the Creation Research Society, which not too many people have heard of. We're a group of scientists and also lay people that mainly focus in on research and publishing. If you're interested in a free newsletter and a catalog, I have a sign-up sheet for the Creation Research Society down at the book table, and some free literature. You can get Creation Matters. I have several samples of Creation Matters there, and also something by Dr. Anderson from our lab on evidences against evolution. That's free down there. So when you browse the book table, take a look at that stuff. And we'll take a little break, and I will continue with some mostly new stuff that I've added to my Ice Age talk. What, 10 minutes, sir?
Yes, 10 minutes, please.
10 minutes. First of all, we'll start with wet deserts. What in the world is a wet desert? It's kind of an oxymoron, but this is what I mean by it. We find that in dry areas all over much of the earth, there's evidence that there is lakes and streams. They've been able to send radar through the sands of the Sierra Desert, and they've seen big drainage areas. They found fossils of crocodiles and hippos in the Sierra Desert, where it was once well watered. They once found a live crocodile in a shriveled up lake in the western Sahara, I think at high altitude. And this was about 100 years ago, so indicating that this different climate was not that long ago. And here is in the southwest United States, based on shorelines that you can see all around these lakes. You find evidence that in the Great Basin, now there were lakes down in here too. These are just Great Basin lakes right in here. There were lakes in Death Valley up to 600 feet deep. This is Lake Bonneville, which is about 8 times the size of Great Salt Lake and about 800 feet deeper. The average depth of Salt Lake is 13 feet, I think, if I recall, something of that order. And this was 800 feet deeper. And you can see, if you fly into Salt Lake, you see the shorelines right along the Wasatch Mountains really easy. Now, how does this happen? Now, well, this takes quite a climate change to fill this up. And uniformitarian scientists have a lot of problems filling up all these lakes. But for us, they are remnants of the flood. When the flood drained, it would fill up pockets that are now dry. And we know that these lakes were maintained for quite a while because sometimes these lakes form shorelines right on terminal moraines in 2 places. One place coming out of the Wasatch Mountains southeast of Salt Lake, and one in the Mono Lake right in here in the Owens Valley. And also, the top of this overflowed through here and down the Snake River